everyone. Hello. Can everyone hear me and see me?
Yes, I can hear you.
Hello? Yeah. I want to confirm if others can hear me.
We can hear you.
Okay, great, great. Before I introduce myself, I am currently in Nigeria, and I think everyone here, are we all from Nigeria? Do we have the same time zone? Before I tell you good evening and stuff.
Okay, if you want to talk, you just
Hello?
unmute yourself and speak. Let's make this session interactive. I'm from Nigeria.
It's actually be interactive, actually. And so let's one by one introduce ourselves. I mean, where are you from? I know your name's already, so where are you from?
Benjamin, I'm currently in Ondo State from Kogi State actually, but I'm in Ondo State. And yeah, so I'm good to be here.
Benjamin is where?
I'm in Ondo State.
Ondo. Oh, okay, okay, nice. Um,
Good evening. I'm Ojola Iwaju from Ogun State, Nigeria.
okay, great, great. Thank you.
Good evening. I'm Israel from Abuja.
Oh, Israel Abuja, welcome.
Thank you.
All right. And the last person we have PS James. PS, could you tell us where you're from right at this meeting? Can PS hear us? Okay. Before I get into today's topic, just a brief introduction. So apparently, um, a little mistake. I currently train machine learning at the Bob Africa. Bob Africa is a technical institution here in Lagos, Nigeria. And then I run a startup that is focused on training teenagers and artificial intelligence tools, basically. We're just making STEM much more accessible to them. And then that's what Levers is all about, the Levers Innovative Program. So, and then I also build models all around imaging, work on research topics, and majorly on research, ML, machine learning, AI researches when it comes to medical imaging. And my university degree really was clinical radiography, that's radio diagnostics, medical imaging. So I have a strong background in medical imaging, especially across modalities, X-rays, CTs, and MRIs. Um, yeah, I want this session to be pretty interactive because I really don't work with slides. I try to share experiential knowledge as much as like researches we've worked on, products we've worked on, um, researches we're currently working on, and a couple of advances in this field. The architectures, the researches, and all of those things. Yeah. So yeah, I would like it to be very interactive. If you have questions around medical imaging and artificial intelligence fused, how to build in that regard, I really welcome them. Um, so yeah, let me just keep on going. When you have any question, just pop your hand up. Yeah. So um, the field of medical imaging has so much changed, right? And if you're very comfortable medical imaging, you realize that um, diagnosis is changing with time. And so there are certain pathologies, X-rays cannot, we can't see on X-rays, um, but then we can see them on CT. Some we can't see on CT, but we can see them on MRI. All right. For example, And then which of these data sets um, um, are much more can be utilized better when it comes to a certain pathology. For example, when it comes to breast imaging, we use mammography, we use low kV mammography, or mammogram machines, right? And so those images, compare them to the breast imaging you do with MRI. So you do breast imaging also with MRI. And it doesn't mean that the fact that MRI is the best visual, has the best visual for breast imaging, doesn't mean MRI breast images are the best, right? When it comes to um, predictive got predictive risk, especially in breast mammograms, right? So what I mean clearly is when we want to build a predictive model, right? So for example, one of the research we're concluding is it's a partnership with MIT. It's a breast cancer risk assessment algorithm. So breast cancer risk assessment. So the way it works is normally in a clinical setting we use certain factors to determine if this particular patient would have cancer in the next couple of years. And the reason is because some cancer appear when they are already at the later stage. And the fact that they are at the later stage means there is no hope for survival or that particular tissue or the whole body. So it's either you excise the tissue and the tumor away, or the person dies out of the illness, out of cancer. So we we've been thinking cancers are sort of, by the time they are in stage three, stage four, when they're actually diagnosable, right? So it's in this stage they can be diagnosed, and they are earlier stage they cannot be diagnosed, right? So they sort of appear right in their later stage. So that's why we sort of want to employ predictive models. And in a conventional clinical setting, the model they use is actually not an AI model. It's a statistical model. It's called a Tara-Cusick model. So what that model is supposed to do is to um, um, we take certain factors, weighed all of those couple of factors, a couple of standard factors, and then so we pass these factors, make them into numerical values, and then there's something we call Tara-Cusick model. So it's the existing clinical model they use for risk assessments, right? Wow, these are the simple things we experience here. All right, are we together? Can anyone hear me?
Yes, you can.
All right, good, good, thank you.
Yeah, we can hear you.
So I hope all of us can relate to what just happened. Okay,
Yeah.
so yeah, amazing. So, um, but then we thought of working around predictive models, especially in breast cancer, in breast imaging, right? So, in this particular research, one thing we realized is the fact that MRI has best visuals for breast doesn't mean it's the best to use to train an AI model for breast imaging, because it's more or less too detailed. There'll be lots of false positive and false negative following the nature of MRI data when it comes to breast imaging. So the best image at this time to use, we don't know about tomorrow if anything comes up tomorrow, but the best is more or less the same mammogram, right? So they're actually novel things. And what this algorithm basically does is it predicts the occurrence of cancer in the next 5 years, and it returns a probability score of the person developing cancer. And it has been proven to some extent sub-Saharan Africa and Europe to really work. This is actually one of coordination tumor treatments, precisely cancerous tumors, right? You have to plan the tumor, radiotherapy before radiotherapy, all right? Plan the tumor dosages and all of those things. It's one of the things we're working on because glioma, which is a brain tumor, all right, is actually one of kills very fast. So one of the things we're doing also is building state-of-the-art custom architectures to detect, to properly segment. Segmentation means you put a proper contouring, precise contouring around the tumor, right? So that segmentation and then classification for glioma tumors. And in this, we use either CT or MRI data. One of the very things I'd like everyone to note is medical imaging is actually progressive, right? When it comes to artificial intelligence, it's very progressive. And then there is this myth around radiologists, they replace this and that. It's a facade because when you're not optimistic about something, you won't be able to adopt it into your workflow. AI will get better, especially in medical imaging. But then we need to see it as an assistive technology, right? It's assistive, right? It's not a sole technology. AI in its best performance is with humans, and humans in this context means radiologists, right? It means they can work together and they work together to get the optimal results. There is a closing time. What I mean by closing time is there is a time limit, right? Just imagine in a low resource setting like sub-Saharan Africa, where the ratio of oncologists or radiologists to the patient is quite high. So how do you reduce the time you spend on each patient results and all of those things? So this is actually places we tend to leverage artificial intelligence in. And a very simple analogy is just imagine you're going through a particular image, could be MRI or CT or anything, and then you have a good AI model that can properly segment all the organs, and not just the organs, segment certain pathology, and then precisely tell you about that pathology. And we're gradually moving to a point where we're infusing medical AI segmentation and classification. We are infusing that with neurosymbolic AI. Neurosymbolic AI is a way of reinforcement learning, right? That is, the radiologist is basically part of the training of the model, the reinforcement, how the model gets better and learns better. And another one is how we can properly infuse medical imaging with Gen AI, right? What it means is we can look through a particular image, find some pathologies, and Gen AI can actually tell us precisely through a very rich, I mean, we know very rich Gen AI sources like Medlama, um, is actually the best right now. Outperform GPT because I think GPT passed USMLE by a certain percentage, and I think Medlama passed like further, right? So we've seen lots of libraries for medical, lots of medical libraries we can leverage on, right? Stored and trained with lots of information all around the world. So there's a bit of meaning to it when we infuse this with certain pathologies we find in medical imaging, and it can provide much more context about what we are seeing. So the radiologist can properly look through and be like, okay, I can adjust to this, I can adjust to this, and all of these things. So these are the things we're looking at currently in medical imaging, why there are so much more going on. But when it comes to diagnostic medical imaging, the 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 main aid we've been experiencing around AI in medical imaging, it's either creating a context around that vision algorithm. So vision algorithm means representation on an image is where we're at this moment. And then one last thing is Currently in Africa, we would be experiencing more of researches than products because um, the research once we finish, we're about concluding, apparently re- releasing a research paper soon. Um, one of the bottlenecks we had was we wanted to validate this algorithm across sub-Saharan Africa in order to eliminate false positive and false negative. And it's the same thing with what we call a genome-wide association study that contains a sort of genome bank of descents, like descents across demographics, like people across demographics. So they store their genome composition, right? And these things are very, very efficient tools when it comes to drug design because targeted cell therapy, they can be able to understand certain biological variants around diseases, right? So, genome-wide association study, understanding the genome of those people you want to target this drug towards, improves the efficiency of that drug. And as of 2021, only about 3% of GWAS globally is Africa, right? Only about 3% of the O2, the whole bank of information contains African data, right? So it shows us that all of the vaccines, especially genomic medicine, RNA vaccines we've been producing, they are they're working here, but they are not particularly for us. And so that's why you have lots of startups working on gathering genome across Africa to improve drug design and delivery for us here. It's the same thing with AI in medical imaging. The when you look at the mammogram of Caucasians or Europeans, Americans compared to Nigerians, you realize that our breast mammograms are many times very dense. They are denser, right? Our colors, our physical compositions, right? So that validate this algorithm because by the time they deploy here, because really they would deploy it here, right? They have more reach, right? They have the money, they have everything to sell the product here. There'll be lots of wrong diagnoses. We might be leveraging AI and stuff, but there'll really be lots of wrong diagnoses. But a very good way to boycott that and make sure there is inclusivity and accessibility when it comes to AI products in health, medical imaging care, we realize we need to first go into research in this space, validate algorithms across sub-Saharan African data sets, and ensure that these things are working for us. So you're not getting false positive and false negative values and all of those things. So yeah, that's where we're at. That's the current phase of medical imaging, especially in sub-Saharan Africa. If you have any questions, you can always just reach out to me. Okay. Yeah.
Okay, I have a question, and after that, if you have also a question, just indicate as I'm talking, just indicate by raising up your hand. So the mammogram data and the other data you talked about, do you get them by experimentation? What is the source, the major source, how you get this data? And then do you run conv nets on these things? I mean, the way you, or you just kind of you're using synthetic data? Do you make use of, to what extent do you use synthetic data?
All right. When you're building when you're working in a clinical setting, you're building a clinical tool, you want to ensure you're as real as possible, right? When you're building around all other domains, right? Construction, engineering, you can use synthetic data. Oh, can you hear me now? Can you hear me now?
Yeah, I heard it to a point. Can you hear me?
Hello, can you hear me now?
Yeah, you stopped at
Yes, I can.
when you are building medical data, like you don't make use of. To what extent do you use synthetic
Good,
data?
good, good. So when you have clinical tools in this domain, trust me, you don't want to use synthetic data at all. It's our own novel approach. You don't want to use synthetic data at all because you're dealing with people's life, right? Especially when it comes to cancer diagnosis and all. So one of the order we experience when we are gathering data from senders, medical practitioners, clinics, and everything, it's a big work, especially when it's a pioneering project, it's a groundbreaking project. It's a big work, and it's what you have to do, right? When you're building around clinical tools, AI, medical imaging, you want to ensure it could be doesn't even have to be medical imaging, artificial intelligence in medicine, anything at all. You want to ensure your data set are as real as possible. If you haven't gotten the data set, you'd have to wait. That's one of the things we're doing now. We are sort of because one of the experiences we had because of this research was many clinics do not have they have data, but they don't have compliant data that can be used for researches. And so one of the things we had to do was to reach out to them, ensure they have good implementation policies, data policies, data management policies, and efficient data management, data strategy also, right? Sorry. All right, sorry about that interruption. So you want to ensure you don't use synthetic data at all, even though there are some domains, right? Especially things like sort of I think 3D 4D segmentations. I think the one they use in coronary angiography. MMMs sort of pioneering this integrating imaging. It's because they have data sets. They have data sets that can learn. They have data sets an AI system can learn from and create similar data sets. We don't even have out of the myriads of data sets we have. Okay, so at this our stage in our current demographics, we should never use synthetic data for anything, right? Because we don't even have enough data for synthetic data to generate from, right? The synthetic data, for those that do not understand, is data that you manufacture yourself that are not particularly within the clinical setting. They were not gotten from the clinical setting, from the patient, from treatment processes, right? So that's it. That's it.
Okay. Before my next question, Mr. Oluwashe wants to ask a question. Please go ahead. Mr. Oluwashe, unmute yourself. Can you hear us?
Hello.
Yes, we can hear you.
I don't have any question, please. Sorry, it was a mistake.
Okay, so Mr. Philip, back to what I was asking. Um, the that means generative AI thrives on mostly synthetic data, right? Can you hear me, Mr. Philip?
Can you? Yeah, I'm with you.
So that means it's not all that recommended for medical field because I have this application. I'm also into the healthcare, machine learning for healthcare. I have this application I came across one time like that. It's developed by two individuals from the UK. It's called MediSearch. MediSearch, where you can prompt it with healthcare questions, and then it gives you responses, real-time response, and also alongside with reference papers where you can look up for this. So, for instance, imagine asking for you're experiencing some dizziness like that, and you don't know what is the cause of this, and then it's able to generate and give you some responses. Although it's by the side, it says a warning that is you should consult your healthcare professionals for more details about it. So, what do you think about that? Is generative AI really appropriate for the healthcare industry?
All right, I think that's a very good question. That's a very good question. However, it's relative. Quite relative. A model like that, you cannot compare it to a model Google or or Facebook built. The reason is because when you look at Medlama or any of this GPT for health, you realize that they most likely partnered with data from clinics. The way Medlama works, it's not just a knowledge you get from textbook. So I can assume medics in search or med in search, the one you mentioned, they most likely will be trained on books, all right, Max books, all right. But one thing I do believe um, um, that of Facebook and Google was created from was that I think research papers are quite factual, right? Research papers, books, clinical documents from clinics, they most likely use an NDA and all of those things. So I do believe for them to build that, they had data from real clinics of patients, pathology, treatment processes, and everything. All right. So synthetic data has no chance when it comes to proper diagnosis. It does have no chance. If you want to build good machine AI models for healthcare, you need to use data through experiential knowledge. You need to use data through experiential knowledge. Yeah.
Yeah, I think I agree with that. Yeah, so do other persons have questions? Please, let's make this session interactive. If you have questions, you can ask. Okay, so when this medical data is acquired, let's say these scans, the mammograms, and all those visual data has been acquired, let's say in their large quantities. Do we proceed with the data pre-processing process, the data cleaning process, and then use techniques like, because from what you're saying now, I think the best approach for most of these medical model development is to use deep learning methods like convolutional neural networks, where you train the model yourself on hardware and then export the model for usage. So, for instance, X-ray and other data like that can be acquired. I mean, gathered, collected, and annotated, and then used for convolutional neural network like that. I guess that those the process remains the same with deep learning methods, right?
Yeah, it's very much the same, but not closely the same. And that's where more research is hard currently about the best architecture, right? The best architecture for getting the most optimized model. There are several steps. There are several steps that matters. You have your data collection, quality of data you get. You have your ground truth because you need your ground truth before you can proceed with training. And even with the ground truth, you need your data annotated and everything, right? And there is data augmentation process, right? Your practices, data practices, um, that's data augmentation process. How exactly, um, how exactly you are tweaking your data, right? Your training sets, your testing sets, and all of those things. And down to your pre-processing, and then your architecture, your convolutional network. I mean, there are lots of convolutional network, and then the researches that pretty much are showing the best, right, the best architecture for for the CNN, right, best segmentation model, with Auto 3D Search, you have Monai. And then also for the CNN architecture, there's a unit, there's a twin unit. I mean, they're using transformer models now, combining transformer models with units, right? There is that too. And a couple of other ones. So the whole idea is what processes, what certain metrics can we look at to create the most optimized model? We're not just building a Glioma segmentation model, just okay, segment and that's fine. No, let's look at the best performance, right? And then what do we need to look at to guarantee the best performance? Do we need to look at more loss function? Do we need to compare architectures? There are lots of research papers around this. You can just go online and read them up. Do we need to look into the optimizers, adjust the optimizers, use certain optimizers, right? So these are all of the things we're looking at. They're pretty much the same, but like not exactly the same. Yeah, different architectures, different loss functions, different optimizers. The whole idea is what can we do, right? To which of these things can we change or use together to create the most optimized model? So that's it.
Wow, that's quite insightful. Yeah, that's it's actually, since it's a research area, mostly I know a lot of persons will be sent trying to see how they can use the best optimizer, and then kind of trying to minimize the loss function and just the best optimizer. That is usually most the area where people center their research on. So guys, once again, this is Philip, and he's a machine learning engineer researcher in the healthcare domain. So you have questions, you have contributions to make. Let's hear you out. We're starting from Mr. Benjamin. So what do you have to say for tonight's program? You have questions or contribution you like to make? You have the floor.
Oh, good evening. Thank you very much. I really don't have any question or anything to say. I have just been listening and then I've just been trying to cut as many information I can.
Okay, great. So, Mr. Ogonna, would like you to share your experience a little bit and the from what you have said so far, and then what you've learned so far, and also your experience in AI as general. Mr. Ogonna, are you there? Mr. Ogonna, okay, if it's not there, Mr. Oluwasei, that's over to you. So, you have questions for the speaker and or contribution.
Yeah. Good evening. I think I don't have much to say, but I think as he has delivered the message very clearly, it makes it more simple for us to understand. But since it's a subject, is a sub area that has more knowledge, we are just all learning. I'm just learning from what he has said. But I've learned a lot of things, like the synthetic data that he spoke about. I was able to have an idea of what it means, and also he talked about the data that are used in medical lines. that they cannot use synthetic data, which I have. I just got a clearer picture of why they can't use that tonight. So I think he has done a very good job. So thank you to him.
Okay, thank you very much for that. Mr. Ugonna, yes, you wanted to say something? Hello, Mr. Ugonna, you have the floor.
Okay, good evening, everyone.
Good evening.
So, as someone who is not in medical field, some of the terminologies were more like jargons to me, but they are medical jargons rather. So, I think he did justice to the discussion. So, what I just need to do is to do some research and learn more on my own. So, like, just it. Thank you.
You're welcome. So, one more thing, I think, finally, concerning this thing, you all have learned from our speaker tonight that machine learning is the way you apply machine learning in other fields like agriculture, say food security, smart city, and in homes. It's not really the same with medical field because of I mean, you're talking about people's lives here, so you don't just come up with model and then, in fact, there are a lot of compliance protocols I have to undergo, and before your product is out there. So is for those of us that are still looking at, okay, what aspect can I experiment, can I go into, kind of venture into? I'm still new in AI, so you can check out the medical field as you have said, and see how you can contribute towards saving lives. Then the 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 other thing I wanted to say, Mr. Philip, is this. I don't know if you're familiar with Internet of Things, IoT. Mr. Philip? Hello, can you hear me, Mr. Philip?
Yeah, I said IoTs and embedded systems,
Yeah.
edge compute.
Yeah, so like, okay, this is just the last one for tonight. Kind of, I was looking at something like that, like, you know, people, when you do IoT, Internet of Things, you tend to relate more with real data. In fact, that was one of the things that fascinated me to the world of IoT before I got into AI. Like, imagine I built a blood pressure sensor. I mean, something that can sense blood pressure and heartbeat of a patient, and also the body temperature of the patient. I'm able to stream this data to a platform like, let's say, Firebase, or a cloud platform, or an edge platform like Raspberry Pi, and I'm able to save this data. Since this data is real, coming out from the real humans. Yeah, you can hear me, right? So since this data is real, coming out from a real human, you think it's really trustworthy to kind of go into that? Because in QIT, in Quantum Innovative, we are focused in healthcare. It's a startup based in Abuja. It's a startup based in Abuja, so we use that to acquire people's health care data, and then we clean the data, and then we try to run our machine learning model through it. So what do you have to say concerning that? I think that should be the last for the night for tonight.
Uh, Really, include community at a very sort of fish. clinic, right? You see, yeah, that and all of those things. Before those things go to the market, research is flow out, right? So they compare the performance of that device with, the conventional practice. So IoTs are really good. However, research goes before deployment into the healthcare. I do believe they're good. Even though things like they're limited, really. For example, you can use Apple Watch precisely for plethysmography. It's like a way of it doesn't interact directly with the internal system. It's just on the surface of the wrist and reads oxygen saturation level using infrared light. Right. So while those technology are getting better, I do believe research goes before. So we know that these things are clinically compliant. And then IoTs are majorly used around health analytics, right? Majorly around health analytics. I think it does well. Or things like blood rate, before they were deployed in the clinical setting. So IoTs can never be displaced when it comes to healthcare analytics. I think in the US there is a device. I know someone who uses it to monitor his sugar level. So they basically sort of it's like a kind of a round cap on the skin and whenever anything happens, whenever shit. Yeah.
Okay, so that will be all tonight, Mr. Philip. We are really grateful to have you tonight speaking to us on machine learning for medical imaging. So, for those of us that attended, I think we have the session recorded. We'll upload it to our channel and then we'll send you the link. So, on your own free time, you can actually go through it and then revert. And if there are questions, you can get across to me or to Mr. Philip. So, Mr. Philip, by this, I'm also inviting you to join our tech community is I mean quantum AI community where we run this program every Saturday. So we really really love to have you. We are hoping to collaborate with other medical professionals and hospital owners so we can work hand in hand to make medical AI a reality in the country Nigeria and Africa at large. So thank you tonight. You're welcome once again. Thank you.
It's a pleasure with you. Thank you.
Alright, so that'll be all. So everyone, stay tuned for our next program, which is on Saturday, and the update will be given to you when it's time. So good night, everyone.